Laplace differential equations. A complex analysis make लाप्लास डिफरेंशियल इक्वेशन है जिसका स्टेटमेंट है रियल एंड इमेजिनरी पार्ट्स एडेस्ट u and b of analytic function fz u plus ib satisfy the Laplace equation. Shortly we can write it in mathematical form. Del 2 u is equal to 0 and del 2 v is equal to 0, and we can in expand form write it in expand form as del 2 u over del x square plus del 2 u over del y square is equal to 0, and del 2 u over del 2 v over del x square plus del 2 v over del y square equal to 0. Now we have to prove these two equations by using Cauchy-Riemann equation. We know that Cauchy-Riemann equation is only applicable when our function is analytic. So we are given here our function fz is analytic function. So we can write Cauchy-Riemann equation. Cauchy-Riemann equations. Del u over del x is equal to del v over del y, and del v over del x is equal to minus del u over del y. By these two equations, which is collectively we write equation number 1, we can prove Laplace equation for u and v. First we prove Laplace equation for real part of complex function it has to u. So we have to prove this expression equal to 0. We can write this as del u over del x. Similarly, this term can be written as del u over del y. By Cauchy-Riemann equation, we can write these values as del u over del x. Del u over del x can be written as del v over del y. Similarly, by equation number 1, we write del u over del x equal to del v over del y. Similarly, we write del u over del y by transposing minus sign to left hand side, and we get minus del v over del x. We put this value from equation number 1. Similarly, this value put in equation and we get this. Then differentiate. Then differentiating, we get del 2 v over del x del y minus del 2 v over del y del x. For continuous function, we know that these two values are equal. Therefore, this cancel out. V is continuous because v is fx is analytic. So fz is continuous. Fz is given that is continuous analytic, so it is continuous. Therefore, v also continuous. So we can cancel out two terms, which is equal to del 2 u over del x square plus del 2 u over del y square. Hence, U satisfy Laplace equation. Similarly, we can prove B satisfy Laplace equation. So we write left hand side for V, del 2V over del y square. We can write this equation as del V over del x plus del over del y into del V over del y. And again using Cauchy-Riemann equation, and we can write this value in terms of u, which is minus del u over del y. Similarly, we put this value by Cauchy-Riemann equation. I have given it equation number 1, and by putting this value here, which is equal to del u over del x, and differentiating with partially respect to x, so we get minus del 2u over del x del y plus del 2u over del y del x. Since u is continuous, therefore we can cancel out this, and we get del 2v over del x square del 2v over del x square. Therefore we can say that v is satisfying Laplace equation. For more videos of such kind, you subscribe my channel. Thank you very much indeed for watching us.